This is a question that we have discussed in class for JJ311 Mechanic of Machine, Chapter 1, Hoisting for Counterweight. So, today I will repeat and solve the problem that you have discussed in class by grouping. I will take off these questions. First, we will build our free body diagram from the questions that we know. A drum, we have the data. Mass of the drum equals to 25 kg. Diameter of the drum equals to 1.2 meters. Radius of gyration 0.19 meter. From the questions, there are two ropes. Tie the end of the ropes, two masses, 65 kilogram and 30 kilogram. Tensional force P1 and P2. From the sub question 1, A equals to 2.5 meter over second square, and raise the 65 kilogram mass. So the motion will be upwards for 65 kilogram and clockwise for the drum, downwards for the 30 kilogram. Take notes that motion is very important to apply the law in our class. Therefore, A always follows motion, and 65 times A for MA for inertia force. Here 65 is 65 times gravity. For weight, also for 30, is 30 times G. Motion downwards, A will follows motion for the counterweight. Therefore, inertial force for the counterweight is 30 times 8. We already finished for the linear equation. A goes to angular section will be alpha, and there will be I alpha. For sub question 1, there is driving torque. So now we have to complete the equation of linear and angular. So I will divide here. We settle for P1 first. Summation of force upwards equals to summation force downwards. We close for the angular motion. The arrow is upwards for P1. So P1 equals to 65G plus 65A. Therefore, P1 equals to 65 9.81 plus 2.5 equals to 800.15 Newton. For P2 section, summation of force upwards equals to summation force downwards. So we close here. So P2 upwards plus 30A equals to 30G. P2 equals to 30G minus 30A equals to 39.81 minus 2.5 equals to 219.3 Newton. Don't forget the units. For the angular motion, summation of torque clockwise equals to summation of torque anti-clockwise. So we analyze all the torque. They are TP clockwise plus P2 times R tangential force times R equals to torque. So plus P2R equals to anti-clockwise is I alpha, inertia times alpha, and plus P1R. Before we settle the equation, we have to settle I and alpha. When I equals to mdk square equals to 25 times 0.19 square equals to 0.9025 kg meter square. Meanwhile, alpha equals to A over R equals to 2.5 divided by 0.6 equals to 4.1667 radian over second square. We can settle the equation when we want driving torque TP equals to I alpha plus P1R minus P2R. TP equals to 0.9025 times 4.1667 plus 800.15 times 0.6 plus minus 219.3 times 0.6. TP equals to 352.24 Newton meter. We can also settle the sub-question 2 when they give power equals to 1.4 kilowatt. Power equals to T omega. We want linear velocity. P equals to T omega. T we can get from the driving torque. Therefore 1.4 times 10 power of 3 equals to 352.24 omega. Therefore omega equals to 3.97 radian over second. V equals to R omega equals to 0.6 times 3.97 equals to 2.385 meter over second. We finish, we complete for calculate for sub question 1 and sub question 2.